There are several buffing systems on the market, and they're all pretty much the same. They consist of wheels that are made up of a stacked series of cloth discs, and we have two abrasives. The coarsest is triple compound, which is jeweler's rouge, and that is about 800 to 1100 grit on the same scale that is used to measure the sandpaper that we use. The fine buffing compound is called white diamond, and that is something in the neighborhood of 15 to 1800. And then the final finish that is put on the wood is a very hard carnauba wax. This is done by 3 wheels. The hardest wheel is used with the triple compound, and that is made from discs of linen. The next wheel for the white diamond is alternating sheets of linen and cotton. And then the wax is applied with a buffing wheel that is 100% cotton. Now these particular wheels are a little different from the ones you normally see at the hardware store. The hardware store wheels are usually sewn in circular fashion, and they are a very hard wheel. These are only held together at the center. The particular ones that I'm using here are those that are made by Beal. The only difference between the Beal system and several others that are on the market is in how the discs are attached to the mandrel. The Beal wheels have 2 washers and a bolt going through them to hold the discs together, and that bolt screws into a threaded hole in the end of the mandrel. The other systems use wheels that are held together by 2 washers with a hole through the center of them, and they slide over a mandrel rod with a nut to hold them in place. So that's the big difference. These are just easier to put on and take off. Can't do anything faster than that. I prefer to run the wheels in the lathe because I have control of the hardness through the speed. As you can see, this wheel right now is running at about 800 RPM. It's fairly soft and fairly flexible, easily conforms to the shape of the wood. I could run it at 1800 RPM, and it's a very hard wheel. My preference is to run that wheel at about 900 RPM. It's a nice compromise between too soft and too hard. The hard wheel is a grabby wheel, and it has a tendency to rip these pieces out of your hand. Before we start a discussion on the buffing, let's talk a little bit about Morris tapers. Morris taper is a self-locking taper. Doesn't require a draw bolt or doesn't require anything to lock it into place. If the taper on the inside of the spindle and the taper on the outside of the mandrel are identical, all that is required is a slight tap to hold it in place. If those two are not a perfect match, or if the inside taper is not clean, or if the outside taper on the mandrel has bench rash on it and dings and marks, then it's not going to be a perfect mating fit between 2 metal surfaces. Then it will be necessary to put the wheel on and then bring up the tailstock to make sure that it stays in place. The only problem with that is you have to remove the tailstock every time you want to change the wheels.